Welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhat College, University of Delhi. So presently in our series of database management systems, we are going through the topic of SQL, and in our previous lectures we have seen that how information from various relations can be combined, one using Cartesian products and another using natural join. So with this, our today's topic is about nested subqueries and modifications of the database. So in this lecture we will be looking for some subqueries which are nested, and what are the ways or what are the different ways in which the modifications to the data stored inside the database can be done. So let us begin with nested subqueries first. So nested subquery, as the name indicates, it is a subquery that is nested within the another query, or we can say a subquery which is a select from where expression. So your query is a select from where expression, and that select from where expression when nested within another query is known as nested subquery. Now when we talk about nested subquery, let us see what are the uses of this. So there can be many uses. One is to perform the test for the set membership, then next is to make set comparisons, and third one is to determine the set cardinality, and these can be done by nesting the subqueries in the where clauses. And now we will be looking into two of these uses. One is the performing the for set membership, performing the test for set membership, and another one is for making set comparisons. So let us begin with when we want let us begin with the set membership here. So when we want to test the tuples for membership in a relation, these nested subqueries can be used, and the connectives or the keyword which can be used is actually the keyword in. So the in keyword or in connective, it is going to test for the set membership, while the set, if we talk about, is a collection of the values which is produced by a select clause. So we will be kind of, we can say, triggering a select clause, and whatever is the set of values produced by a select clause, we will be looking for some particular values available into that using the connective in. Similarly, if we use the connective not in, that will test for the absence of the set membership. So for the for checking the presence of set membership, it is in, and for the absence of set membership, it is not in. So let us see this with the help of an example. So we have seen find all the courses which are taught in both fall 2009 and spring 2010 semester. So please recall this query. This we have done with the help of union. That is we have done one query was taking out the information for fall semester 2009, and another query was taking out the information for spring 2010, and that was kind of combined using the intersecting so intersecting both the sets. It's not the union but intersection of the sets. So the first, the set of courses taught in fall 2009 and set of courses taught in spring 2010. So because it is talking about both, so we will need to take the intersection, not the union. Sorry, my apologies here. So with this intersection, we have done this query earlier. Now what will be the alternative approach? The alternative approach for finding all the courses which belong to this criteria, that is they were taught in fall 2009 and in spring 2010, we are going to write a query with using the connective in, and that query goes like this: select distinct course ID from section where semester equals to fall and year equals to 2009, and course ID in, within another bracket, select course ID from section where semester is equals to spring and year is equals to 2010. So here we have taken two separate queries, one nested inside the another one using the connective in. So, select distinct course ID from section where semester equals to fall and year equals to 2009, and course ID, because we need this course ID also to be in spring 2010. So, we write and course ID in, select course ID from section where semester is equals to spring and year equals to 2010. Now, similarly, one more query which we have seen earlier, that was find all the courses taught in the fall 2009 semester, but not in the spring 2010 semester. So, which are which are the members of the set fall 2009, but not the member of spring 2010. So, with this the we can say the set operation which clicked in our mind is the set difference operation. So, here for reflecting that set difference operation in an alternative way, we will be using not in. So, select distinct course ID from section where semester equals to fall and year 2009, and course ID not in, select course ID from section where semester is equals to spring and year is equals to 2010. So, here not in is going to give us kind of the functionality of the set difference. So, we have seen the how to check the set membership, how to check the set membership using our nested subqueries. One is not, one is in, another one is in, another one is not in. Similarly, the another idea of using this nested subqueries is the set comparison. So, let us see the example of this set comparison. So, set comparison says find the names of all instructors whose salary is greater than at least one instructor in the biology department. Earlier also we have seen this query, and this query in the earlier format goes like this: select distinct T dot name from instructor as T, and we have also seen aliases here, comma instructor as S, where T dot salary greater than S dot salary and S dot department name equals to biology. So, we have we have in a way taken multiple instances of the table instructor. One has been renamed as T, another one has renamed as S, and then we have performed some set comparison using the greater than operator along with this where clause, where T dot salary greater than S dot salary and S dot department name equals to biology. So, if we want to use this set comparison operator using the nest, or if we want to establish this set comparison operator using the nested subquery, we will be writing select name from instructor where salary greater than sum, within the bracket the nested subquery goes within the bracket, select salary from the instructor where department name equals to biology. So, how this query is going to be evaluated? The query inside the bracket, which is select salary from the instructor where department name is equals to biology. So, all the salary figures will be extracted for department name is equals to biology. Now, that becomes we can say a set here, a resultant set. Now, the query, the whole query goes like this: select name from instructor where salary greater than sum of that particular set. So, here also we are going to here we are actually using this keyword sum for the set comparison. So, we can use greater than sum, less than equals to, or not equals to sum and equals to sum, and all these comparisons can be used when we want to establish the methodology or when we want to establish the functionality of set comparison using our nested subqueries. So till this we have seen what actually a nested subquery is, and we have seen the usage of nested subquery in set membership and set comparison operations. Now further we will proceed to the modification of the database. So when we talk about the modification of the database, one thing which we should be very clear is that modification of the database actually does not mean the modification of database structure. Here I am not going to disturb the schema or the structure of the database through the commands which I am going to tell now. These are the commands which are there only for the data which is stored inside the database. So let us take that. So first we will take deletion. So deletion is about deletion of tuples. Please remember that this can delete only the whole tuples. The specific value inside the tuples cannot be deleted using this particular delete command. It cannot delete the values on only particular attributes. And what is the SQL query or proper SQL query for deletion is delete from the relation R, whatever the name of the relation is, where a predicate. Now if we are going to omit this where clause, all the tuples in the relation are deleted. So if we are going to write delete from all is going to delete all the tuples from the relation R. And if we say, let us say, delete from instructor where salary greater than 80,000. So in this situation all those tuples which are having salary greater than 80,000, all those tuples can be deleted. Also please note that a delete command is going to operate only on one relation, but it can have, with where predicate, it can have various kind of, we can say, variations. Some of them are listed here. So delete from instructor where department name is equals to finance. The interpretation is very simple. All those tuples from the instructor will be deleted where the department name is equals to finance. Then delete from instructor where salary between 13,000 and 15,000. So whatever the salary figures are, if there is a salary figure in between 13,000 and 15,000, that particular table that particular tuple will be deleted from instructor. Also one use of nested subquery in case of delete. So delete from instructor where department name in. Now in is a connective which is used for set membership, which is used for testing the set membership in case of a nested subquery. So delete from instructor where department name in, select department name from department where building is equals to Watson. So basically from the department table, all those department names will be extracted who are going or who are taking place, who are getting holded inside the building, inside the Watson building. So all those department name which are hosted inside the Watson building will be taken up, and any the the values from the instructor where department name comes under this criteria, that will be deleted. So all those instructor values will be deleted whose department is actually hosted inside the Watson building. So here we have used the set membership using the in connective, using the connective in, and we have also used a nested subquery along with the delete. So this delete can go from a very simple form like delete from instructor to a very complicated form as we have just seen, in which a nested subquery is also we can say used. So delete is going, as I have told you, that delete is going to delete is going to delete the tuples from only one relation at a time. But in case of a select from where we can reference any number of relations in this select from where expression, and also we have seen that we have also just seen the example of a nested subquery in which the where clause is being used. So yes, generally we can say that tuple will delete from only one relation, but there are uh, you know uh, examples, or there are ways in which multiple relations can be referenced inside a delete operation, but ultimately the delete operation will be executed only on one relation. Similarly, this was about deletion. Similarly, we can say deletion. Similarly, we can quote the just opposite operation of deletion, that is insertion. So insertion goes like this: insert into course. Course is the name of the relation, values, and then whatever value you want to insert, those values are to be inserted. So now here please be careful that I have not used any of the attribute name, that this attribute is going to take this particular value, or this attribute will take this particular value. The sequence will follow here, that is the CS437 will go in the first attribute, which is the course ID, then database systems will go in the second attribute, which is the title, then the department name takes up the value computer science, and the credit will have the value 4. So here we have not disturbed the sequence of the attributes in which they are hosted inside the relation. So then there is no no need of mentioning the attributes names separately. We can just mention the values, and we will say insert into course, insert into course values. First value will go inside the first attribute, second value will go inside the second attribute, but please be careful about the matching of the domain types. This query can also be written in a more clear way, in which we are going to write the names of the attributes and what value will go inside those attributes. So here we have seen, we can see that insert into course, course ID, title, department name, credits, these are the names of the attributes, and these attributes will take the values CS437, database systems, computer science 4. This can be the one idea, or the earlier idea is also fine if we are not disturbing the sequence. But if we are disturbing the sequence, that is the first value we want to get inserted inside the title, the second value we want to get inside the course ID, the third inside the credit, and that means we are jumbling up the sequence of this course ID, title, department name and credits, and we are not following the sequence which is there in the relation. Then it is mandatory to write the names of the attribute as it is shown in the third query, which says insert into course, title, course ID, credits, department name. Now here we have changed. The first field in the relation was course ID, but here we are not writing the course ID first. Please see the third query, which says insert into course, title, comma, course ID, comma, credits, comma, department name, values. Now values will go like this particular sequence which we have just specified: title first, which is database systems, then course ID, which is CS437, then it will be having credits, which is 4, and the department name, which is computer science. So we can always jumble up the we can say sequence of the attributes, and in case of jumbling up, it is necessary to mention the titles of the attributes or the names of the attribute here, so that the data can be hosted in a in a proper manner. Similarly, we can also insert various tuples on the basis of results of a query. Results of the query, as in, let us take the example. So, for example, we want to make each student in the music department who has earned more than 144 credits an instructor in the music department. So all those students of the music department who have earned more than 144 credit hours, they can be made as instructor in the music department with a salary of, let's say, $18,000. So how are we going to, kind of, we'll be taking some information from the student, and that information from, or that resultant set from the information of the student will be, we can say, inserted inside the instructor. So we will be writing insert into instructor, select ID name, department name, comma 18,000. As we are fixing the salary as 18,000, we can write direct 18,000 here. From a student, where department name is equals to music and total credit greater than 144. So the ID name and department name and the value 18,000 will be inserted inside the instructor, and the rest of the information will come from the next table, which is student, and the what all information will be taken from the student, that is department name is equals to where the department name is equals to music and total credit greater than 144. Now this is what we inserted the tuples on the basis of a result of a query. Now for example, if we are going to write something of this sort, which is insert into student, select star from student. So we need to select all the values from the student, and those values will be inserted into the student as well. So what do you think, what will happen in these type of cases? So here this might insert an infinite number of tuples if the primary key constraint on the student is not available. If there is a primary key constraint and the primary key constraint said the primary key cannot be duplicate, it has to be unique, this will stop somewhere. But if there is no primary key constraint, then a query like this, that is insert into a student, select a star from a student, is going to result in an infinite number of tuples inside the student relation. So yes, that we have need to be very careful. Now, but one question which generally comes up in the mind of a learner, that when we say that insert into a student and then there are values, is there in a better way of kind of inserting the values in a faster way, as in we are doing here using the insert command, we are inserting the values record by record, or we can say tuple by tuple. So yes, the answer is there are most of the relational database products which are available commercially, they have a bulk loader utility to insert a large set of tuples into a relation, and how from where this large set of tuples or large set of data comes, that is, these utilities allows the data to be read from formatted text files and can execute much more faster than an equivalent sequence of insert statements. So we need not to be worried about writing these insert statements for each and every tuple, that we need to write a separate insert statements. We have bulk loader utilities in order to insert a large set of tuples in a relation from a formatted text file also. So this was about your deletion and insertion. But after insertion, what happen if we want to kind of update the value, or if we want to change the value of one particular attribute? So for example, we want to increase the salary by, let's say 5% or something like that. So here is the update command. We can write update instructor set salary is equals to salary into 1.05. So salary is equals to, so the new salary will be the previous salary into 1.05, which is going to give kind of raise of 5%. So, the new salary will be 5% raised from the previous salary, and all the records in the instructor relation will be updated with this new salary. Now, let us say we can also include the where clause with this salary with this update thing. So, if a salary increase is to be paid only to the instructor whose salary is less than 70,000, we will be writing a where clause in a very simple manner as update instructor set salary is equals to salary into 1.05 where salary less than 70,000. So, wherever salary is less than 70,000, only those records, only those tuples will be updated, and those instructors will be given a salary raise of 5%. Or let us say another criteria says give a 5% salary raise to the instructor whose salary is less than average. So, here first of all we need to find the average salary, and then we need to apply a set comparison here, as in update instructor set salary is equals to salary into 1.05 where salary less than, within the bracket, a nested subquery which says select average salary from the instructor. So, selects average salary from the instructor is going to give us a particular set with within that particular average salary, which is going to be a one member set, whatever salary figures which are less than average will be given a raise of 5%. I will just repeat the query here once for more clarity. Update instructor set salary equals to salary multiplied by 1.05 where salary less than, within the bracket, select average salary from instructor. Now, sometimes it happens that order of update also becomes very important. Now, let us now suppose that with in this context, let us take this example. Suppose that all the instructor with salary greater than $1 lakh receive a 3% raise, whereas all others will receive a 5% raise. So, we could write two update statements. One is update instructor set salary is equals to salary into 1.03 where salary greater than 1 lakh, and the second update is update instructor set salary equals to salary into 1.05 where salary less than equals to 1 lakh. Now, here the order of the update is also very important. If we are going to reverse the order of the update, that is salary less than less than equals to 1 lakh is updated first, and greater than 1 lakh will be updated later on. If we are going to change the order in such a way, an instructor with a salary just under 1 lakh would receive an over of 8% raise. So, sometimes you need, if we are performing multiple updates, we have to be very careful about the order of the updates as well in order to get the correct results. So, here in this lecture we have seen the nested subqueries and their usage in checking the set membership and set comparisons, and after that we have seen about modification in the values stored inside the database. Within that modifications we have seen how to update, how to delete, and about the insertion statement as well. Here is a list of references which is being used for the preparation of the lecture. Hope you have enjoyed it. I will see you in the next lecture. Till then, happy learning. Goodbye. Take care.